We've been studying our solar system for hundreds of years, sent probes to every planet, and landed robots on Mars. And yet, some of the most basic things about our own cosmic backyard still make zero sense. Here are 7 solar system mysteries that scientists genuinely cannot solve. Every planet in our solar system rotates counterclockwise when viewed from above the North Pole. Every planet except Venus. Venus rotates clockwise, meaning its sun rises in the west and sets in the east. On top of that, Venus rotates so slowly that a single day on Venus is longer than a year on Venus. Nobody knows why Venus spins backwards. The leading theory is that it got hit by a massive object early in its history that flipped its rotation. But another theory says Venus's thick atmosphere created tidal forces that slowly reversed its spin over billions of years. Neither theory fully explains it. Saturn's North Pole has a giant hexagonal storm system that's about 20,000 miles across, bigger than Earth. The Cassini spacecraft discovered it in the 1980s and we've been studying it ever since. The hexagon is made of a jet stream moving at 200 miles per hour, and it's been stable for at least 40 years. Scientists have recreated similar shapes in lab experiments by spinning fluids at different rates, but nobody knows exactly why this particular storm formed a perfect six-sided shape and why it's been so stable for so long. The surface of the Sun is about 5,500 degrees Celsius. But the corona, the outer atmosphere of the Sun that extends millions of miles into space, is over 1 million degrees Celsius. That's like walking away from a fire and it gets hotter instead of colder. This is called the coronal heating problem, and it's been one of the biggest mysteries in astrophysics for 80 years. We know the heat comes from magnetic fields, but the exact mechanism, whether it's nanoflares, magnetic waves, or something else, is still debated. NASA's Curiosity rover detected methane burps on Mars. On Earth, 90% of methane is produced by living things. So finding methane on Mars is a big deal. But here's the mystery: the methane appears and disappears in patterns that don't make sense. It spikes at certain times of day and in certain seasons, but the European Space Agency's orbiter couldn't find any methane at all when it looked from above. The methane might be coming from underground chemical reactions, or it might be coming from microbes deep below the surface. We genuinely don't know. Uranus rotates on its side. Its axis is tilted 98 degrees, meaning it essentially rolls around the Sun like a ball. This means each pole gets 42 years of continuous sunlight followed by 42 years of darkness. The leading theory is that an Earth-sized object smashed into Uranus early in its history and knocked it over. But some scientists think it was multiple smaller impacts, and others think a massive moon could have destabilized its tilt and then been ejected. The real answer might be a combination, but we won't know until we send a dedicated mission there, which isn't planned until the 2040s. The Oort cloud is a theoretical shell of icy objects surrounding our solar system at a distance of up to 100,000 times the Earth-Sun distance. It's where long-period comets come from. The problem is, we've never seen it. At that distance, the objects are too small and too faint for any telescope to detect directly. The Oort cloud exists only because we can see comets that seem to come from it, and our models of solar system formation predict it should be there. But we have no direct evidence. It's an invisible structure the size of a light year that we're forced to believe in based on circumstantial evidence. The leading theory is that a Mars-sized object called Theia crashed into early Earth, and the debris formed the moon. But there's a problem. When scientists analyzed Apollo moon rocks, they found that the moon's chemical composition is nearly identical to Earth's. If Theia hit Earth and made the moon should have some of Theia's unique chemistry mixed in.